cover section 2.3, drawing conclusions. After studying this section, you'll be able to follow a 5-step procedure to draw logical conclusions. When we draw conclusions from given information, we want to follow this procedure. First, we want to memorize our theorems, definitions, and postulates. Then we want to look for keywords and symbols in the given information. We want to think of all the theorems, definitions, and postulates that involve those keywords. We want to decide which theorem, definition, or postulate allows us to draw a conclusion. Then we want to draw our conclusion and give a reason to justify the conclusion. We want to be certain that you have not used the reverse of the correct reason. Okay, looking at a few examples, we're given ray AB bisects angle CAD. What can we conclude? Well, there's two pieces of information that I want to identify. The first is we have ray AB, and then we have bisects. Remember, the definition of bisect is split into two congruent parts. So if the ray bisects the angle, that would mean that angle CAB is congruent to angle BAD. So that's my appropriate conclusion. Problem 1, we're given angle A is a right angle, angle B is a right angle. What can I conclude? Well, if I have angle A, right angle, and angle B, right angle, then I know that those angles are congruent. Because of my very first theorem that we learned, the right angle theorem, if two angles are right angles, then they are congruent. So if I was to have this in a proof form, I would have my two givens. So A is a right angle, that's given. B is a right angle, that's given. Then my conclusion, angle A is congruent to angle B, by the reasoning of if two angles are right angles, then they are congruent. Problem 2, we're given E is the midpoint of line segment SG. What can I conclude? Well, there's a few things that I can conclude here if I wanted to. If E is the midpoint, that also means that E is a bisector, because remember, midpoint means two congruent pieces. And if I have two congruent pieces, then I have a bisector. So E could be a bisector, or I could say line segment SE is equal to line segment EG. So let's go with line segment SE is congruent to line segment EG. Again, in proof form, I'd have my first statement as my given. E is the midpoint of line segment SG. Then my next statement would just be line segment SE is congruent to line segment EG, because if a point is a midpoint, then it splits the segment into two congruent segments. Notice how I have the if a point is a midpoint first, because that's what's given to me in the problem. I can't say if a point divides a segment into two congruent segments, then it is the midpoint of the segment, because I'm trying to prove that it is congruent. So I can't have that first and then state my actual reason. Again, the logical flow is the statement above first, then the reason to follow. Looking at problem 3, we're given angle PRS as a right angle. What can we conclude? So the key word here is right angle. I know that if we have a right angle, obviously angle R would be 90 degrees. However, I also know when we have a right angle, the two lines that form the angle are perpendicular. So I can conclude that line PR and line RS are perpendicular. So in my proof, I'd have angle PRS, right angle, that's given. Then line PR is perpendicular to line RS, because if an angle is a right angle, then the lines forming that angle are perpendicular. So if two lines intersect to form a right angle, they are perpendicular. Looking at another example, we're given line AB is perpendicular to line BC. What can I conclude? Again, keywords here would be perpendicular. What happens when something is perpendicular? Well, I know if something's perpendicular, then it's a right angle, or it measures 90 degrees. So I can say that angle B is a right angle, or angle B is 90 degrees. Looking at my second example, I have angle DEF is comp to angle HEF. So again, looking at keywords, I have comp or complementary. So if I have two angles that are complementary, I know that they form a right angle. I also know that the lines that intersect would be perpendicular. So I could say angle DEH is a right angle, or I could say line DE is perpendicular to line HE. Looking at another, I'm given ray QS and ray QT trisect angle PQR. Again, looking at my keyword, I have the rays trisect the angle. What happens when I trisect? my angles are all congruent. So I could say angle PQT, angle TQS, angle SQR are all congruent. My next example, I have line WZ bisects line segment VY. So if I have line WZ bisecting, remember bisect means to split into two congruent pieces. So VZ would be equal to ZY. I could also say that point Z is a midpoint. And then my last example, I'm given line CG bisects line segment BD. What can I conclude? Well, if I have my line here, CG, bisecting BD, that means BF is congruent to FD. It would also mean that my point in the middle would be a midpoint, so F is the midpoint. So I could have line segment BF is congruent to line segment FD, or F is the midpoint. In this lesson, we learned to draw conclusions, look for keywords in your given statements that relate to the theorems, definitions, and postulates that you have memorized. That's a wrap on this video. We'll see you in the next one.